So today we are officially starting Chapter 9. We are going to be using the graphing method to solve a system of linear equations in two variables. Solving systems of equations is probably my favorite part of Algebra I and Algebra II. Okay, I really enjoy this chapter. I hope you guys will also. Today is not going to be that bad if yesterday was pretty easy for you. Today we're going to be doing a lot of graphing, but it's going to be as easy as it was yesterday. So we have to first identify slope and y-intercept. So that's what our warm-up is about. What letter do we use for slope, Keon? M. And what about y-intercept? B. So on all of these we have to identify M and B. First one's not too bad. Who can help me out with M and B on number 1? May?
2 and 1.
2 and 1. Okay, our slope and our y-intercept are easy to identify when it's already in slope-intercept form. Is number 2 in slope-intercept form? No. Can anyone tell me how they think we should rewrite it to put it in slope-intercept form? Ellie?
Y equals -x plus 3.
Wonderful. We just had to switch those around, the -x and the 3, but you have to keep the right sign with the right term. So because it was -x, the x stays negative, the 3 was positive, so it becomes +3. After we rearrange it, then it becomes easier to identify M and B. Who can help me out with M and B on number 2? Connie?
M is 1 and B is 3.
Very close. M is -1. Good. So -1, B is +3. All right, number 3, is it in slope-intercept form? No. Who can tell me what to do to get it there? Ryan?
Divide 2 on both sides.
Do what on both sides?
Divide 2.
Not divide. We want to move that 2x.
You want to add 2?
It's already positive.
I'll subtract 2.
Very good. Subtract 2x, not just the 2, but the whole thing. So we subtract 2x from both sides. We have y equals -2x plus 6. Remember, we've got to be careful about the order we write it in. And then we would be ready to identify M and B. Who wants to help me out with M and B on number 3? Shannon? Wonderful. M is -2, B is 6. All right, for number 4, I'm going to rewrite it off to the side because I don't have a whole lot of room down there. So I'm going to put number 4 over here. Is it in slope-intercept form? No, it is not. Who can help me get it there? Deja? Good. We subtract x from both sides. We have 2y equals -x plus 8. Is it in slope-intercept form now? No, still not. What's the next thing I have to do?
Divide by 2.
Divide everything by 2. Okay, every single piece gets divided by 2. So we have y equals, what number is between this negative sign and the x? A 1. So -1/2 x plus, what's 8 divided by 2? 4. All right, But we're not done. We still have to identify M and B. Who can help me out on this one? Needing some new volunteers today. Kion, thank you. Mm-hmm. Wonderful. Questions about our warm-up? We all feel good about identifying slope and y-intercept? Okay, hopefully that means yes. All right, so some of our notes for today. 2 or more equations in the same variables form a system of linear equations. So when it says in the same variables, it means they use the same variables. So both equations use x and y. That's what it's going to look like most of the time for us. To graph a system, you must find all ordered pairs that make both equations true. I would rather that say solve instead of graph. So I would maybe write solve above that. I feel like that makes a little more sense. We're going to graph both of the lines, but to solve it, we're looking for the points or the ordered pairs that make both true. To find a solution to a system of linear equations by graphing, you must graph both equations on the same coordinate plane. I think I might have mentioned this to this class yesterday, that all we're doing today is graphing. We have 2 lines on each plot, on each grid. When we have a system of equations, we've got a few different possible situations. Okay, there will be one solution if the lines intersect at one point. So if the lines touch each other at just one point, there is one solution. Does anybody remember what it means for lines to be parallel? Ellie?
Is there one where means they don't cross each other?
Good. So if the 2 lines are looking like this and they don't cross each other, how many solutions do you think there will be?
2.
So if here they intersect at one point, there's one solution. Do they intersect here? No. So there's no solution if they are parallel. If they do not touch each other, it will have no solution. Finally, if your lines are exactly the same line, meaning you go to your coordinate plane and you graph one of them, and you go to graph the other line, and it's the same exact line on top of the last one that you made. If it's the same exact line twice, there are infinitely many solutions. Infinitely many solutions. Because that means that every single point that is on the line is a solution. We'll keep going then. One of the things I like about systems of equations is that you are always going to be able to check your answer. Always, always, always. So, we'll practice that now. Determine whether the point 3,5 is a solution of the system. For it to be a solution, it has to work in both equations. Does anybody think they know how we would check to see if this is a solution or not? Kian? I don't think I want to add any of the x's. 4 times 3. So what are you doing? Right, but why did you put a 3 there? Good. So this is x. We're going to plug x in. We're also going to plug y in. We're going to see if when we plug that point in, if it comes out to be true. So what's going in for y? 5 equals 4 times 3 minus 7. What is 4 times 3? 12. What is 12 minus 7? 5. So we end up with 5 equals 5. Is that true? Does 5 equal 5? Yes, that's true. So it worked for that one. But that does not mean that we are finished. For it to be a solution, it has to work in both of the equations. So now we have to go next door to the x plus y equals 8 and see if it works there also. So again, what's going in for x? 3. What's going in for y? What is 3 plus 5? Does 8 equal 8? Yes, so that means it is a solution. So your answer would be yes, or you could put solution, something like that. That point is a solution. We're going to do the same kind of thing on number 2. So I want you to take a moment and plug in x and y. I don't care which equation you start with. If you come up with one equation where it does not work, you don't have to do the other one. But if it works in one, you got to check to make sure it works in both. We'll talk about it in just a minute. All right, in order to do this, we are plugging what in for x? -2, and what's going in for y? 1. So when we rewrite this problem, we use parentheses to help us keep those separated from each other so we know that we're doing what operation? Multiplication. So what is 2 times -2? -4. What's -4 minus 1? -5. So does it work for the first one? Yes. So it works there. That's fine. That does not mean that it's a definite solution because we still have to check the other one. So we go to the next one. We plug in -2 and 1 again. What is 3 times -2? -6. What is 2 times 1? What is -6 plus 2? Does -4 equal 3? No, it does not. So because this does not work, this is not a solution. So no. All right, we are going to graph each system of linear equations and determine the solution. So in order to do this, we're just going to graph both lines. And then we're going to figure out where they cross each other, if they cross each other. So for line 1, let's just on this consider line 1 to be the top line, line 2 to be the bottom line. For line 1, who can help me out with identifying my slope and my y-intercept? Deja? M is 1 and B is what? 0. Perfect. So remember, if there is not something written after the x, no plus or minus after the x, your y-intercept or B is 0. Who can help me out with line 2? Shannon? Wonderful. Our slope is -1. Our y-intercept is 6. Okay, then we have to graph both of those lines. Do one line at a time, all the way through, like draw the whole line, and then go back and do the other one. I'll do it in 2 different colors so you can see them separately. You do not have to do it in 2 different colors. You'll see why in a little bit, but just for this one, we'll do 2 different colors. So line 1, I was using purple. My y-intercept is 0, so that's where I'm starting off. I put a point at the origin. I need to get more points using my slope. This is what we reviewed yesterday. If I wanted my slope to be a fraction, I would put the 1/1. So that means my rise and my run are both +1. They're both positive. We are going up and to the right. Up and to the right, up and to the right. Okay, or instead of going up and to the right, we could go down and to the left. I hope that by repeating that every single time we do it, we remember to do it when we're working on our own. We've got a bunch of points now. Let's make sure we get our line put in. Remember yesterday I emphasized that we need those lines to be going through the whole graph. The better you can line it up with the points, the easier it'll be to identify your solution. Also on these, the more points you're able to fit on your line, probably the better off you'll be at identifying your solution as well. It's just a helpful hint. We only have to have about 3 points, but I would recommend putting a lot more than that if you can fit them on there. Okay, now let's go to line 2. Where am I starting my line 2? 6 on the y-axis. And what is my slope, rise over run, for line 2? -1 over 1. So -1 over 1 means I'm going which direction? Down 1 and then over which way? To the right. So if we give the negative sign, we treat it like -1 over 1. We give the negative to the top. That means the bottom is positive. So down 1, right 1, down 1, right 1, down 1, right 1. And we keep doing that. So hopefully if you made a lot of points on both lines, you can already see that you would have covered up the same point twice when you did this. But either way, we should still put our actual line through those points. That's a little better. All right, so then our goal here is to identify the solution, or where the lines intersect. I'm hoping we can all see where they cross each other is this point right here. So we just have to identify that point as an ordered pair. Can anybody tell me what that point is? Keon? 3, 3, I would agree with that. So we went over 3, up 3 to get to this point there. So our answer on these are going to be ordered pairs unless there's no solution or infinitely many solutions. But if your lines cross each other at just one point, your answer is going to be an ordered pair x, comma, y. So who can help me out identifying my M and B for line 1? Shannon? -1 and 0. And what about M and B for line 2, Ellie? 1 and 6. Okay, so the numbers here look similar to the last problem, but they are different lines. So graph both of the lines, see where they meet each other. If you want to graph in different colors, if that helps you keep them straight, you can. You do not have to. All right, so we have our M and B for both of these lines. So we start graphing them. My first point for line 1 is going to go. Anybody? Keon? 0, 0. It's at the origin. My slope is -1. To write it as a fraction, we could put it over 1. So where am I going to go? I'm going to have to start getting new hands or we're getting the popsicle sticks out. Brian?
Go like down one and then to the right.
Wonderful. We can go down 1, right 1. We can keep moving in that direction. Or instead of going down and to the right, we could go, Deshaun, up and to the left. All right, so we have several points. We can go ahead and graph that line. Next, we move on to line 2. Where is line 2 starting? I know most of you graphed it, so I know more than just a couple people know where to start that line. Delaney?
6.
Up at 6 on our y-axis. Okay, so we're up at 6, and then our slope is 1 over 1. We can only go up 1, right 1 time, so I would recommend reversing it and going down and to the left a few times. Notice that because we made enough points for both lines, we actually traced over the same point twice. That's helpful. Sometimes if you just graph a couple points and draw your lines in, if they're not perfectly straight, it's hard to actually tell where they should intersect. But because we traced over the same exact point for both lines, we know that that is where they are touching each other. So that point is our answer. Who can identify that point? Natalie? -3, 3. I would agree. And just like we did on examples 1 and 2, we could check this solution in that system. These are the two equations we would use. This would be the XY pair that we would plug in. And if we were to plug it in, we would find out that it works for both equations. All right, number 5. We need to identify M and B for both of our lines again. I'm looking for people I have not heard from yet. Jamal. Wonderful. For line 1, we've got -1 and 1 for our slope and our y-intercept. What about line 2? Jalen? 2 and -8. Sounds good to me. So then we just have to work on graphing both of those. My graph gets a little cut off at the bottom here, but we'll do our best. All right, line 1 is going to start at 1 on the y-axis. Then our slope is -1 over 1. Remember, anytime that we have a slope written as an integer, we can always put it over 1. So if you want to do that right away, go for it. -1 over 1 and 2 over 1. So we're using -1 over 1 for line 1, meaning we are going to go down 1 to the right 1. Put several points on there. If we go down and to the right, we could also go up and to the left. Once you have several points on there, then you can plot your line. Okay, there is our first line, all the way through that graph. Next, we've got to go to line 2. Where is line 2 starting? -8 on the y-axis, which it is on there. It's just getting covered up on my screen. All the way at the bottom there. Okay, then my slope for line 2 is 2 over 1. So I'm going to go up how many? 2, and over which way? 1. To the right. Up 2, right 1. Keep doing that several times to get a nice good line going there. Then we can plot the line on the graph. Once again, I traced over the same point twice. That's why it's helpful to put lots of points on your graph when you graph these. Who can identify where those two lines intersected each other? Keon? 3, -2, I would agree. So 3, -2 is our solution. All right, on number 6, we need M and B for both of these lines. Who can help me out with line 1? Ellie?
B is 1 and M is 3.
Wonderful. What about line 2? Jakeem, why don't you help us out with line 2? Three and -8. Wonderful. We go to graph these lines. What do we notice before we even start graphing? What's the same? Keon? Those 3s. The slope is the same. Okay, if you did not already know this, that is a trademark of parallel lines having the same slope. So even before we graph them, we probably can already tell what our solution will be, or what our answer will be, but the directions ask us to graph, so we'll go ahead and graph them both. We start up at 1 for line 1. We could put the 3 over 1 to get a rise and a run. So we rise 3, go over 1, rise 3, go over 1. Okay, we can put a line in through those points. It's not a great line. That one's a little bit better. Okay, where is my second line going to start? Where should I put my first point for line 2? Jalen? -8. So we go down to -8 on the y-axis. Our slope is the same, so we're still going up 3 over 1, up 3 over 1. Okay, and we can graph our line again. Now we already kind of gave it away before we got started, but these lines do not touch each other. They are parallel, which means our answer is no solution. So instead of writing an ordered pair, you would write no solution. Questions about number 6? All right, let's wrap it up with number 7. Now, once again, just by looking at the problem and reflecting back on your notes, you can probably see what's going to happen here. But we'll go through all of our steps. What is M and B for line 1? Nevaeh, I don't think I've heard from you yet today. What's M and B for the first line?
B is -1.
Wonderful.
M is 2.
Beautiful. So we got 2 and -1. What do we notice about the second line? It's the same exact line, which means it's M and B are the same exact thing. So when we go to graph line 1, really we're also graphing line 2. We start at -1 on the y-axis. Our slope is 2 over 1, so we rise 2, run 1. We can do that a few times. Graph that line. Now I will switch colors for the second line just to be consistent. But what's going to happen when I start graphing it? Kian?
They're both going to be on the same line.
Yeah, I'm going to end up graphing all the same points. I graph -1, I go up 2 over 1, up 2 over 1, and all my new points are lying on the same exact line that I just made. So I can graph it again. Same exact line. Does anybody remember or can look back in their notes about what that means, Shannon? There are infinitely many solutions. Every single point on that line is a solution. That line extends on and on forever and ever. So there are infinitely many solutions.